welcome everybody. My name is Corey Lambertson with Asiga. And today I'd like to thank everybody for joining our webinar series. Today we're actually going to be broadcasting on the industrial application side. And so just before we get started, all of this is going to be recorded. It'll be on YouTube here in a few days. And so please go ahead and watch again as needed. Watch as many times as you want. And of course, share with all of your friends and colleagues. So today we are going to be talking with polySpectra. And so polySpectra is a very exciting company because they are on the leading edge of photopolymer science for 3D printing. This is the next generation materials. And on this webinar itself, we're going to discuss the industrial additive manufacturing applications of polySpectra's COR Alpha material, which is now available for most Asiga 3D printers. This is including the Pro 4K, the Max X, the Asiga Max, and even our Pico generation that is no longer being sold, but it is validated on the Pico2 generation 3D printers. COR Alpha is currently being used by Fortune 500 firms and U.S. government agencies across the U.S. to develop high-performance components for automotive, aerospace, robotics, defense, electronics, and the list goes on for what this material can be used for. The unprecedented combination of working high temperature and toughness and chemical resistance and biocompatibility now unlocks many high-value end-use applications for the Asiga user group. So I'm going to go ahead and actually turn this over. I have the pleasure of introducing Raymond from polySpectra. He's the founder and CEO and mad scientist behind this. Raymond, go ahead and how are you doing today?
I'm great. Yeah, thanks for having me on. I'm happy to share some mad science.
Yeah. Well, it's the whole photopolymer science, I know just the smallest amount, and it's because my brain is about this big, but ultimately it's so unique in how all the different chemistries are related, and it really feels like you guys have unlocked that next generation. And so go ahead and tell us about yourself. Who are you, Raymond?
Sure, yeah. So my name's Raymond Weidekamp. I'm the founder and CEO at polySpectra, and I am a chemist by training, and my PhD specialty was really at the intersection of organic chemistry, polymer science, and applied physics. So I spent most of my time specializing at that kind of intersection of light matter interactions and working on polymers that had unique optical properties through nanostructures was one thing, but then invented this new mechanism for photopolymerization, leveraging olefin metathesis. And don't worry, we won't get too nerdy with molecules on this webinar, but yeah, the technology that the company is based on came out of my PhD work when I was a graduate student at Caltech.
Awesome. Well, I believe you have a deeper presentation, and you're going to show some of the awesome applications that this material can be applied for. And then at the end, if anybody has any questions, please feel free to send them through, and we'll go ahead and answer them once we get to the end of the webinar.
Awesome. You want me to start my screen share now?
Yeah, absolutely.
Okay. Let's see if I did it right. Can you see that?
Absolutely, you're good.
Okay, all right. So yeah, I think the main game plan for folks is that we're going to save most of the Q&A to the end, and probably best to use the Q&A function. We're excited to see so many people joining, and I'll let kind of Corey keep an eye on that in case there's something that is super urgent. But yeah, so I'm super excited to join here today. We've been big fans and customers and users and collaborators with Asiga for many years now, and it's really fun to be a part of this community and to be here today to share some of the solutions that we're working on together. So first, I want to give a little bit of an outline of the presentation today. So we're calling it Industrial Additive Manufacturing with COR Alpha and Asiga. There's a few different applications that we'll highlight at a high level, and would love to follow up in the Q&A if folks have specific questions around maybe their application, or if it's top secret, we'll give you the right contact info for our team to chat offline, because this will end up on YouTube. So keep that in mind. So yeah, so I'm gonna just start with like the TLDR and have two slides of the most important things I want you to know, and then everybody can sign off if you're if you're busy. I'm joking, but yeah. So I mentioned in the intro that the chemistry behind this was an invention that I made in graduate school, and the reason that we decided to focus on 3D printing and the white space that we've set out to solve in this space, I think one simple way of plotting it is just the ability to do tough and hot at the same time. And this is just a classic challenge in photopolymers, where you have materials that are, pretty tough. There's lots of materials that have, higher toughness than us or higher elongation and break than us, but they will deform at even kind of modest temperatures. And then similarly, there's plenty of materials with even higher HTTs, but, you're talking about 1 or 2% elongation at break, very brittle. And so what we set out to do, and are now excited to bring to the Asiga customer platform, is do tough and hot together. And so the first product we call COR Alpha, and we've been very much focused on this tough and hot spec for many years now, and bringing the product into a form factor where it's a true drop-in to existing hardware. And I couldn't help but put about a year ago we were on with Justin, and he's said some very nice things about our system on that webinar, and maybe for folks who were on that one, at that time a year ago, we were actually only available for a very specific build of the Pro 4K. That was kind of a special edition that the Asiga team put together for us. But for today, the exciting thing that we wanted to announce is that we now have this resin available for basically all of the hardware that's been out there for the last, I don't know, 5 years. And Corey can probably correct me if I'm wrong, but the Pico2, the Max, the Max X, the Pro 4K, the resin that's sort of ready to go, if you click through resin.polyspectra.com, is for the 385 nanometer models. But at this point, I could say that if you've got a 4 or 5 nanometer printer, we can help you, and but probably as of today, I probably need to email the team about that to just sort of set that up and clarify. So 4 or 5 is a recent development that's coming down the pike as well. But so those are really like the TLDR, which is like, hey, this is ready for this whole family and universe of printers with Asiga, and now these printers that many of the folks on this call already have, really have a number of new capabilities in terms of printing true engineering grade, production parts with very high performance properties. So what I want to do in terms of that outline that I showed earlier is I'm first going to show a little bit of the sort of technical data, because I think that's important to understand the applications. Then we'll highlight a few applications. Then I do want to share some and clarify some of the requirements for printing with this, and then we'll get into the questions at the end. So this is I don't know, a very visceral few second image in terms of what's the differentiator. So I will not besmirch the name of the black engineering grade photopolymer on the right, but what COR Alpha can do in terms of durability, impact strength, is really unique, and so we like to again, we're friends with lots of folks who make nice materials. We don't want to crap on them, but we do like to smash other people's hearts. So again, I mentioned this, like the specific white space that we set out to solve is, a lot of challenges in 3D printed polymers in general, and especially in photopolymers, is, poor working temperature, they're brittle. You have anisotropic properties where, the Z strength isn't the same, all kinds of degradation, leaching, cytotoxicity, all of these things. And so that's really what we're out to solve. And then to just highlight a little bit more quantitatively where we are first on the mechanical side, and then I'll go to thermal. This is a very rigid polymer. So, we've got, I guess I'll do some stuff on camera and some stuff with slides, but, this was a fun part we did called the space wrench. But, so this is very rigid, but it has the unique ability to still fail in a ductile manner. So there's a plastic deformation that happens. So instead of snapping at the UTS, it actually yields. I don't know if you can see my mouse. There's a little sort of notch there that's an artifact from the way we do the test with an X sensometer, so you can ignore that. But then we, so the UTS is about 65, 70 megapascals, and then it'll yield and turn over. And we've set the spec for COR Alpha to be at least 20% elongation at break. Sometimes we get higher than that. Every now and then you'll get a dog bone at 100. At that point, you're kind of once you're in that plastic deformation, there's sort of like a statistics game of just like when is that crack going to get big enough to pop the part. But so this is really, really solid mechanical properties where there's very good stress retention, but there's still flexibility. So maybe like the snap fit buckle would be a good example of that, where it can deform enough to click into place, but it can also lock, right? So that would maybe be a more visceral way of explaining what we're looking at on this curve. And then on the thermal properties, unfortunately, I'm at home and not set up to safely demo high temperature here in my home office, but we have incredibly high glass transition temperature. I probably would say that we're the highest TG of any photopolymer that's out there. There are some folks who, through different filling strategies, have heat deflection temperature that's higher than COR Alpha, but the resin network of our material, I don't know. I can't off the top of my head think of another system out there that's higher, and if there is, it's definitely not tough. And so, depending on how you want to think about working temperature, we have some customers that use our materials in applications up to 200 C. Obviously that's not going to be a load-bearing condition. That would be something like mold insert for an injection molding process where it's getting hot and cooling relatively quickly, or like a fixture on like a high temp process line, like an end effector or something. If you're under a load, you probably want to stay under 130, but again, that's still hot enough to be in under the hood, hot enough to be in a undisclosed automotive application that Corey and I will share later. We have a surprise for everyone later, and a tease to get you to come hang out with us at Rapid. But yeah, on the thermal side, it's incredibly high working temperature. And one thing that I'll add to this that I don't have a specific slide on, but we have almost no moisture absorption. And so this is not only is there really high chemical resistance, but because of this toughness, working temperature, and no moisture absorption, this is definitely better than printed nylons, especially like sintered powdered nylons. But in many cases, we can be better than injection molded nylons because a lot of the challenges with some of those materials is related to the fact that they just suck up water, and some of these nylons can have like 1 or 2% by weight water. So yeah, so I highlighted some of these. So in addition to that, grade 0 cytotox every single time we've ever tested it, and we do that quite regularly, and very, very low dielectric loss. And so this is a very good dielectric. I don't have on here the breakdown voltage off the top of my head, but that's another application that we use this for. So it's very good insulating material for electronics applications as well. And the spec sheet is at this link, and we'll have lots of links and contact info as we go. So yeah, with that context, and again, apologies for folks where it's just like, whoa, like what's a HDT, what's a TG, why are we talking about that? I think it's important foundation for showing the technical differentiation of the product, and now I'd like to just jump into some applications. So this is always a fun slide. I've used this a couple times, and I had the same slide when I talked to Justin a year ago, but unfortunately, like most of our really cool stuff is top secret under NDA, but I can assure everyone on the line that our best customers and biggest customers right now are at the cutting edge of additive manufacturing. Almost all of our customers are in a category where they have tried everything. They have tried every material, every printer, every process, and they still can't do what they want to do in terms of true production, additive manufacturing, digital manufacturing. And so we're very active in auto and aero and other kinds of industrial like vehicles and equipment, in defense things. Robotics and automation is an important one. We have a number of things coming down the pike in medical and dental that I'm personally very excited about, but don't have quite ready to share today. I will show some cool stuff towards some applications that are relevant to consumer products, and we have some pieces on electronics. So my hope is that the folks watching this, both live here and later in the recording when we post this on YouTube, are gonna look at some of these and all of a sudden start to see oh, there's that one component that we're thinking about for our project. So I don't want this to be completely exhaustive, or to I could spend, I don't know, we do 90 minutes on connectors if we wanted to. But yeah, like the first one I want to highlight is in electronics. So again, not the conductive part of electronics, but the insulating material. So connectors and enclosures, different components, fixtures, brackets, applications in 5G, applications in clean rooms, end effectors. There's a whole bunch of things where you really need a good dielectric that is not going to crack on you, that's chemically resistant and can withstand some temperature, especially on these process lines or under the hood things. And as for example cars become more connected, I mean I think there's, I don't know, I forget how many miles worth of cable in a modern car that's selling today. There's, I don't know, 20 different computers inside every car nowadays. And so as sort of everything moves towards this kind of highly connected Internet of Things, one thing that maybe most folks don't know is behind the scenes of that are lots and lots of little connectors fitting all those things together. So this is a really cool application area and very challenging to do, and having high resolution and good materials properties is really key. We've shared this one in the past, but it's just like a fun highlight. So in the end, we did not go all the way through FDA with COR Alpha for RespiraWorks, but it was a really fun story at a very scary time, very early on in the pandemic, where we actually helped this not-for-profit group get all the way through like true functional prototyping with this this valve in the bottom, not the Venturi valve, but this flow valve in the bottom right. They did, I don't know, a million or a couple million cycles on this thing towards their regulatory approval with our part. And in the end, this ended up getting manufactured in India and distributed largely in India with a CM that was capable of just like turning on millions of these things all at once. But it was a really cool opportunity to just showcase the power and the agility of these materials. And this was something where, they had tons of FDM printers, they had tons of friends at different service bureaus with all kinds of different processes, and they just weren't able to actually use those prototypes because they kept cracking because the accuracy was off, and so this is a really fun one. And what I'd love people to see in this and maybe start to think about in this is, what other kinds of connectors or fluidics for, let's say, a medical device application or biotech assay application where you need that chemical stability, a bioinert material that's grade 0. That's kind of where I want people's head to be at for showing this slide. We also, this is something I will say, I did not found the company with the mission to be the best in rapid tooling. My founding idea was, hey, actually, if this thing worked, you'd never need a mold ever again. you just print what you want in the shape that you want it in exactly as many as you want, and you're good to go. But one of the really fun things and like humbling things, and it's been a fun process for us to learn a lot about, is rapid tooling is a real market and a really important application. And there are tons and tons of things where either you don't want to requalify the material, or you do ultimately need a really, really high volume run, and you want to iterate along the way. So most of the molding stuff that we've done I can't show, but this is a demo part in collaboration on a project we're working on with our collaborators at Oak Ridge National Lab, which is a DOE National Lab facility that is really some of the world's experts in 3D printed tooling and rapid tooling. And there's a bunch of really cool research projects that we have going on with them. So on this one, I apologize for not having more data. Most of it's kind of locked up under NDA in terms of like what materials hit what number of cycles. But I'd say that we're, I don't know, between 2 and 10 times longer lasting than what most people use for rapid tooling in the context of a mold insert for injection molding. And we have some stuff coming down the pike with collaborations where we're working on making really, really high performance mold inserts that could start to rival, what you'd call like soft tooling, so like aluminum, CNC aluminum tooling. And it's relevant to not only injection molding, but reactive injection molding, other kinds of, molding of, thermosets, polyurethanes, as well as blow molding are all different applications that we've done. So this is one where, I love to see what people come up with and how we can help. Okay, on the more like direct printing consumer products, this one I'm really excited about. We announced this very recently, a partnership with a specialty powder coating company called Keeland. They have a product called UV Max that I have just the green one here live with me in my hand, but we showed a number of different colors on this press release together. So what's really fun about this is we can get to a, you print a million of these and then say, okay, I want 100 that are this color, 20 that are whatever, my brand blue. So the end solution here is basically I wish I could sort of let everybody on YouTube and Zoom touch this, but it really has that kind of feel of a consumer grade part. And maybe, I don't know, some of the folks on here watching will know that, powder coating is a very, very common process for finishing consumer products. And so it really gives it that really nice feel, and it lets you take basically the same set of printed parts, and now all of a sudden you can turn them any color that you want. And Keeland has the expertise to actually do color matching. So whatever your brand color is, just tell them the color position and they can match that. So it is a second process. This is not like what the print looks like out of the printer. It is, COR Alpha coming out of here. But what's really fun on the more nerdy technical side is we called 15 powder coating companies over 2 years who all told us it is impossible to powder coat plastics. And vice versa, without sharing too much from their side, Keelan spent about 2 years working with other types of additive polymers, trying to powder coat them, and you can't do it. So they were really excited about our material because it, even what they will brand as a low temperature powder coating is actually really high temperature, and it'll warp most printed parts. And then you have to think about adhesion, durability. So, this one is probably not for your like prototype one-off, but this is a way where we could, have COR Alpha provide the durability and resilience of the material, and then Keelan can do the color matching and do any color. And then this next one that I want to share is still slightly secret, under wraps, but it's another coatings partnership that we're going to announce very soon. And this is a different type of coating where we now have like one of the world's most high performance rugged ceramic coatings that is now on top of one of the world's most rugged high performance photopolymers. And so we're really excited about this. I couldn't help but show this picture, and this is something that we're going to jointly announce soon. And this the geometry that we're showing off here is an example of something that's become really fun and really important for us, which is lightweighting for vehicles. So improving the energy efficiency of vehicles through lightweighting, whether that's a car or airplane or truck. And this strategy is called Topology Optimization. So this particular geometry is kind of a demo part from Topology, our friends over there. And with this combination of, again, I wish I could sort of hand this to every single person on there, but this combination of this really high temperature and abrasion resistant, chemically resistant coating, not only you get all these different colors, but now you can really actually start to think about true metal replacement with this combination of polymer and different coatings. And I think that will also be the theme of metal replacement will be something that Corey and I are working closely on, and we'll share in a slide or two. So then one other really fun one that I want to show, let's see if this video will play in a second, but massive market, $2 billion global skateboarding market, really, really important. This was a fun, just a really fun collaboration that we had with a company called Gen 3D, and they designed these, and I reached out and I said, hey, what are you going to make this out of? And they said, oh, we hadn't really thought that far ahead. We just wanted to make a cool render on the computer. And so let's see if this video play. Can you hear the audio, Corey? Awesome. Yeah, so
the first ever 3D printed skateboard wheel. I don't know, but definitely the strongest.
So this is, I'll stop it a little short, but I'm not sure it's the first 3D printed skateboard wheel. It might be, but I am definitely sure that it's.
We can call it the first durable 3D printed
okay.
skateboard wheel.
Nice. There you go. Just add one modifier that will then make you the first.
Yeah.
I think that's the classic rule in marketing. So yeah, this is a really fun one, and we have some videos up and a few more things coming down the pike with this. So again, I can't imagine that there's a ton of folks on the call from skateboarding companies, but this is really an application where we've had a few folks who come visit the office that have been in 3D printing for 35 years, and were kind of had their heads explode when they were like, what? Like, you can do that with a photopolymer? So this has been a really fun one, and one that we're excited to share a little bit more about. So, oops. I'll just go to it. So what Corey and I are working on is extend this into, let's combine lightweighting for vehicles, extremely rugged additive manufacturing, and fun recreational stuff. And so we're printing Corey a bunch of motorcycle parts for his dirt bike for Rapid, which is coming up in a couple of weeks. And Corey, you want to share a little bit about the project from your side?
Yeah, absolutely. So we have a we have meetings on how can we be different and attract different ideas and think kind of outside of the box for 3D printing. And especially at these shows, everybody can print, a cube, or they can print a lattice, or they can print these different structures, but they don't actually show them in play. And so I ride dirt bikes for fun, for the most part fun. Usually I fall a lot, but hey, it's still fun. And I was like, hey, you know what? I have this sweet dirt bike. Why don't we actually duplicate some parts? And so I actually found a company called Diverse Dimensions. They're based out of Grand Rapids, Michigan. They actually did the digitization for us. And then I reached out to polySpectra. I was like, hey, Raymond, this is going to be a really cool idea. Do you want to go ahead and print some parts, and let's actually run it through its paces? And so we'll actually have the dirt bike on display with printed parts from polySpectra on the bike. And then once the actual show is over, I'm going to run it through its paces. And so I'm actually going to go ahead and hop on the bike, and we're going to record it all, and we'll actually see me. Well, it may be somebody that's actually good at riding, abusing the bike, but we'll actually have it actually running through its paces and really abusing the parts. And so, I'm pretty excited to see it and play. Standing on foot pegs that are 3D printed, like you're not going to see any other material that can handle that. Even doing a kickstart, a kickstart lever, that's a lot of force, especially on a spine shaft. And so I'm pretty excited to actually put it through its paces and see what we do.
Yeah, we're working on it. We've got a few different permutations on this that we're cooking that maybe we're not quite fully reveal in this call, but it's going to be really fun at the very least. And if a few of them don't break along the way, then we weren't pushing the envelope hard enough.
That's right. And just another little note for anybody that is attending Rapid TCT, it is May 17th through the 19th. It's based in Detroit, and we're at booth 1749. You won't miss us. There'll be a big dirt bike there.
Awesome. Yeah, that's really going to be great. And I will say from my side that, one, this has been a really fun project for our team to work on, but two, we were very honored when Corey said, we're going to have lots of different components of the part from the different materials partners that we have, but I'm going to save the really, really, really hard ones.
Yeah. Well, it's true, as a 3D printer manufacturer that's open, we're friendly to all of our partners, but these parts here are the parts that take the most abuse. And so I know
we like being abused
because polySpectra has that unlocking that next generation material. These are the true test.
Yeah. So we'll see if we pass, but we're having a lot of fun along the way.
Yeah.
Awesome. Okay. Oops. Here we go. So without further ado, I do want to, as promised, share a little bit about the printing requirements, and then we'll get through just a quick summary and go into the Q&A. And so, again, asking folks to use kind of the official Q&A thing instead of the chat for the questions that you have for the end. But yeah, so in terms of the printing requirements, so we are, here we go. This is a material that is meant for industrial applications, and in its current form factor, let's say, needs to be treated with respect. And this is, not something that we advise folks to be printing kind of, at their house, in their office. And so this is very much, the current form factor of the product. Obviously, we want to work very hard to increase access to this, make things even simpler and even easier to use. But, this is manufacturing. And so, the very first question that you'll see if you're on resin.polyspectra.com is, what type of work environment are you located in? and it's really key that, you know, this is a manufacturing facility, this is a lab, this is like a professional environment where, you know, you've got SOPs in place, and so yeah, we have this broader mission of democratizing manufacturing, and right now that needs to start in facilities where people have those SOPs, that EH&S infrastructure, and is not for your home. And in fact, we cannot even right now, if you give us a residential address, the purchase is going to bounce. So it's got to be a commercial address for us to ship it to you. So that's where we are right now, and, you know, happy to keep folks updated and collaborate to make sure that everybody's set up safely. And I will say that we're working very hard on simplifying these requirements and lowering the cost of these requirements to give more and more people access, and really clarifying in a simple way, like, hey, here's, you know, the 3 things that you need to be successful printing this material. So this presentation is sort of one start of that, and it's something that, you know, my whole team right now is really actively working on, you know, clarifying a lot of this even further. So we do need ventilation, and so I've shown just one picture here of how we have our Pro4 case set up in a recirculating hood. So this is not like a full-on walk-in chemistry fume hood that's like pumped into the HVAC system of the building. It's just a recirculating system. And again, our team, and I'll give our, you know, support at polySpectra email address later on this, can help with various different ways of setting this up. For the smaller printers, you can do different kinds of like snorkel systems or sort of fume extractors. If you're in a lab, you can, you know, we have on our R&D lab, we have lots of Picos and Maxes in proper chemistry hoods. But basically this, you know, it's very important to have the ability to ventilate the printer and then the station where you're cleaning the parts. And so again, that's something where, you know, we can help with providing some recommendations for enclosures that fit specific printers. We do have form factors of this where it's, you know, it's benchtop, but kind of with some VOC control, you know, built in. So it doesn't need to be like a complete remodel of your facility, but we do need to like set up the operators to, you know, to be running this material safely. Then another thing that you'll see on the website on the resin.polyspectra.com is that because the working temperature of this is so high, so, you know, depending on how we measured it, we shared earlier, you know, the TGs between like 165 and 175 C, depending on the way in which you calculate it, it goes through a thermal post-cure. And so actually one thing that I'm very excited to announce today is sort of a way that we're working to make this simpler and lower the burden in terms of the requirements. But our gold standard post-process involves a vacuum oven, so an inert oven where we get the part to 160 C under vacuum for about 90 minutes. And then, you know, it's fully baked at that final working temperature. The thing that we're very excited to share today, and this is not quite ready for purchase today, but ready enough to announce and share, and will be available very soon, is we've actually, this has been definitely a sticking point where a number of folks have basically said, well, I've got an oven, but I don't have a vacuum oven. And so we have a new product called CoreCure, which is a workaround that actually enables customers to work in a normal oven, so don't need the vacuum or the nitrogen, but now the part is kind of submerged in this heating oil fluid that's sort of helping it shoot the gauntlet and get to its final TG with protection from oxygen and air. So that is very exciting. And again, like we are happy to work with customers on, okay, what's, you tell us what's your preference. Okay, we can set you up with these different ovens. There's a number of vacuum ovens that are only a couple $1,000 and they're great. If that's just not in the cards, then we can set up an ambient post process with this CoreCure post-bake protection fluid. Then also right now we're storing the resin in a chemical fridge. So this is, again, something that you want to have ready in the facility to, be able to, store it for long periods of time before use. So those are really the main things that, again, there are lots of materials out there in the more like engineering grade additive manufacturing where none of these things will come as a surprise. There's probably a handful of folks on the call today that are like, yep, I already have all that for, this other process that I'm running. There's also probably folks on the call who are like, what the heck? Like, I don't have any of that for my, desktop kind of DLP. And so we just want to make sure that we're being as clear as possible of like, hey, like, let's make sure that you're set up with all these things. We're happy to advise on the safest way to set things up, the, recommendations for different equipment. And actually, I'll thank Justin from Asiga for really, pushing me a little bit of like, hey, we need to give people like the sort of full package and just like, hey, like, here's everything that you need to bring this forward. So that's something that we're happy to help with, and we're working hard on continuing to clarify it as we go forward. And again, I'm happy to answer any more like specifics on that for folks in the Q&A if that wasn't clear. And again, on our side, we're working hard to build out some documentation and checklists of like, okay, don't place the order until you got all this stuff in place. And we've got a INI file that will load on, I don't know, the last 5 years worth of Asiga printers ready for customers. Obviously, that's not easily displayed in PowerPoint form factor, but we've got the print settings validated for all the different printers, both the ones that are actively for sale as well as ones that you might have purchased in the last few years. Okay, so just I want to wrap up with like a quick summary of like some of the different. So obviously today the main like announcement was on the resin side. Hey, we've got the resin ready, for the Asiga customers. But I do want to just quickly run through like some of the different modes of engagement that we have with people depending on where they are in terms of having additive manufacturing capabilities in their own organization. So for some folks, we can start all the way at the design side. This is, we're not like the best in the world at this, but there's some stuff on the implicit design side, topology optimization, design for DLP, and the design for COR Alpha, which is like, closely connected to kind of design for DLP, but we have a very good understanding of like, okay, what are the, features that we're really good at? What are the like minimum overhangs and things like that? What are the minimum through holes, etc.? We can help with that stuff if necessary. And we have a lot of experience doing that. Again, for folks who are, want to, try something out, send us your STL file at polySpectra.com. We'll print it for you. We're not a giant high volume service bureau. It's not our current plan to like scale as a giant service bureau, but we have a parts service as a way of engaging with customers, showing people what we can do, and getting parts into people's hands quickly and doing application development. Obviously, with the main announcement today was on the resin, and this is a fun video of doing a bunch of little tiny electrical connectors on the Pro 4K, and just this idea of like, hey, if you really did have production AM in-house, how fast could you innovate? How fast could you iterate? You know, what's possible in that world with your facility. So the main, you know, call to action there is resin.polyspectra.com. This is also kind of the main banner on the homepage as well for the live website today. And then there are a number of applications that where people say, hey, you know, this is cool, but could you do black? Or like, this is cool, but could you do, I don't know, 200% of break instead and only 100 CTG? So if you are, you know, a manufacturing company, durable goods company, OEM, with an impossible problem, very specific product, and you know what the problem is, and you've tried every material and it doesn't work, we can help you. Partners at polyspectra.com is the team that leads those joint development agreements, and that is something that we do quite regularly. I do want to do a little shout out on a new initiative that we launched at South by Southwest a few weeks ago that we're calling Massless, and this is really the mission to lower global energy usage by 25% by the year 2050 using distributed digital manufacturing. This is like a whole webinar in and of itself, but you can find out a little bit more at massless.dev. And one of the first tools that we put out there that I think is really, really fun, and I'm biased because I sort of came up with it and helped build it, but it's really fun, and it's kind of the one piece of this puzzle, which is like, if you're just going to print something to look at it, and you know, like everybody on this call know, okay, I designed something in CAD, it's on the screen, and then you print it and you're like, oh dang, that's kind of small. Like, oh, it looked really cool as a mesh, but then like the light, I don't know, it was like a little too dense once we actually like printed the final thing, and I thought it was going to be more open. Those kinds of things, like if you're just going to look at it, it's just a look like prototype. Like, do you even need to print something? And so the AR tool, the current form factor of it, drop in your STL. It'll instantly, if you know, you need to be an AR compatible device, so a tablet or a phone. If you do it on your desktop and you have your STL on your desktop, it'll give you a QR code to hand off to your phone. But you just get the AR preview like right there and see it on your desk and just try it out. And it's a really fun tool. Obviously, just this on its own isn't going to reduce global energy usage by 25%, but it's a really fun, fast way to try things. And then you can actually change. One of the things that's fun right now, you can change any color you want. So you could actually use it maybe as a way of previewing that, you know, that color matching that you want to do later. Obviously the default color is meant to look like COR Alpha, but you can tune the color once you drop in your STL. So anyways, those are my plugs. You know, TLDR, COR Alpha is very tough and it's ready on the Asiga printers. And with that, would be delighted to answer any questions.
Absolutely. We actually had quite a few come in. And so the first question actually was, before you got to the meats and potatoes of the presentation, was what kind of applications have you used this material for? And so
yeah,
we got to see a wide spectrum, whether it's connectors or automotive parts, and even medically related parts as well, that it can be used for.
Yeah, let me maybe just a quick fun way of recapping it all. Instead of going back to all the slides, I'll just show some of the stuff I have on my desk. So like, you know, we've got gears. This is a little demo gear that's really fun. A lot of people think that our material feels a lot and has similar properties to Delrin, which is a very popular material to make gears out of. Obviously, for things like the enclosures that we were talking about in electronics, you know, the ability to do a snap fit connector, whether, you know, this is like a belt buckle example, but this would be equally important for an electronics connector or, you know, a snap fit enclosure. Obviously, lightweighting structures. This is the space wrench, which I taught myself in topology using. This is the first thing I built in topology to learn how to use the software. So, you know, high strength, lightweight, kind of latticed out stuff is great. We have a lot of folks doing impellers. And we didn't actually show a slide of this, but I'm happy to sort of share publicly that it's a cool capability that we have. It does add a little bit of lead time and cost, but so for something like a bioreactor, this could be really amazing, right? Because you're not going to be cooking, microbes higher than our working temperature. It's, it's grade 0 cytotox. That's great. But if you're doing like a jet turbine blade, like you probably still need some of the surface thermal and tribological properties of a metal. And we actually do have the ability to electroplate COR Alpha. And I can see if I can, oh, here. I've got one that I can show off with a nickel finish that we did with Sean at Repliform. But this, so this, it adds some complexity. It's a secondary process, but this will, and depending on how thick it is, the quantitative stiffness that it adds can be very different. But you can actually now get the surface tribological properties, the surface thermal properties, the surface electrical properties of a metal at the price point and the geometric freedom of a polymer and the weight of a polymer too. And so for something like, an impeller that would traditionally be CNC'd aluminum or steel, you could actually start thinking about doing, COR Alpha. And then, so again, this bar, just to super clarify, is this on the inside and a very, very thin layer of nickel electroplated on top of it. And then obviously skateboard wheels, incredibly important, large market, and gyroid based designs is an important application area for us. And then, yeah, I mentioned earlier just this, lightweighting, so brackets, enclosures, fixtures, so many things are made out of aluminum just because it's cheap and available and that's what people know how to use. But so obviously, like, you're not going to make a rocket engine out of this. It's not quite hot enough for that. But there's a ton of things under the hood of a car, in a truck and a tractor and a motorbike, dirt bike, motorcycle, etc. That COR Alpha can actually be a metal replacement. So hopefully that was an exhaustive answer, and we'd love to hear what you guys come up with. That's kind of the whole point.
So we had another question that came through, and so I'm not sure what these are.
Oh,
maybe you will.
ECDP?
Yeah.
So this is the like Paul Jacobs lingo for the critical exposure and the penetration depth. So this is Paul was the original head of R&D at 3D Systems and is a really fantastic guy and has written about 3 books on stereolithography and rapid tooling. And he's not the original inventor of stereolithography, but he developed a lot of the photophysics of how photopolymers work. So off the top of my head, the rough answer, Ariane, is about 150 millijoules per centimeter squared EC and about 150 micron DP. And like, don't quote, I mean, I guess I'll be on YouTube. Don't quote me on that. We can send out links with, especially for the Asiga printers, like the print profiles that we use. We do need more light than a traditional acrylate photopolymer. So for our current product, the dose for 150 micron thick layer is about 600 millijoules per centimeter squared on most of the Asiga printers. But one thing I didn't mention at all early in the talk is the viscosity of our material is incredibly low. So the viscosity of COR Alpha is about 30 centipoise, which is at least 10 times lower than pretty much any other photopolymer out there. And so some of that speed or print time we can make up for in separation mechanics because we don't have to go quite as high or be quite as careful with the separation.
That's good. Thank you for the answer. So another question we got is, when printing for strength, do you need to consider part orientation, nesting, And then what digital tools do you currently use for modeling part strength?
Yeah, so we have a white paper where we show the isotropy of COR Alpha, and in the we strive for isotropic properties, and when the processes kind of run correctly, the parts are isotropic. So that said, there's always going to be some stair stepping. I don't know if this will zoom up close enough, of the layer lines that will take you away from, that. So orientation is important. I would say less from a strength perspective and more just from like support structures and like how long do you want to wait for this to print. Yeah, we have lots of different tools. For simpler things, we'll just use Composer from Asiga and just load them in there while we're building the build. If it's something that needs much more complicated structures, NetFab is one that some of the folks on our team like. And then in terms of the modeling, the finite element tool that I've built, and we can try to include, I don't have a link for this in these slides, but I did build out a full finite element model within Topology to actually model the mechanical failure modes of COR Alpha. And we did a whole webinar where for the space wrench, we actually predicted exactly where it would fail when it broke. And then we ran this finite element to try to figure out, so the ultimate tensile strength of the material, the stiffness, and then we basically figured out at what load this thing will eventually break. So yeah, I guess my short answer is Topology is the one that we have the most experience with directly, but obviously if we can just give you all those mechanical parameters, you could do it in ANSYS or something else.
Awesome. We had another question about the stability of the resin. What happens if it's stored at like room temperature? I mean,
yeah, so on the time scale, so right now, this is obviously something that we're working on sort of, improving over time. Right now, I think the guidance, and this is something that, we can send documentation to for folks in a follow-up, is basically, if our teams actively using the resin and running prints and using it, we'll leave it on the bench, right? If you want to, sit on the resin for, more than a few days on the time scale like weeks, then it's best to put it in the fridge in terms of just getting like the exact same kind of printability and print profile. And so then, so if you're going to sit on it for a week, put it in the fridge, pull it out and, let it warm up and then put it in the printer. We do print at about 30 C set point on most of the Asiga printers, and that's built into the INI file that we've prepared. And then for if you really need, for whatever reason, like you just can't get to it and you're going to sit on the bottle of COR Alpha for really long, months before you can print, then right now the recommendation would be to freeze it, and the shelf life is quite long. But yeah,
there's no issues with freezing your resin
as long as you thaw it all the way. Then you're fine.
That's pretty cool.
So yeah, it's cool. So again, there's different decisions. In anything chemistry, you're always balancing like sort of stability versus reactivity, and we've also at various points thought about maybe do a 2K system where you'd overcome that, but I don't know, a lot of the feedback that we've gotten is people don't like those, so this is what we opted for. And if it's a problem, we're happy to work with with folks on making it work and making it real for their application. But yeah, right now recommend having a fridge if you're gonna kind of hang on to the resin for a little while.
Yeah. And then we have two more questions left. The second last question is, how much does it need for thermal post curing? And so I don't know if
the goal, we have a number of different ways to get it to a full cure. The sort of gold standard typical way that we run in production. Like we run the Pro 4Ks, we clean them off, and then we pop them in a vacuum oven at 160 C for about 90 minutes.
Okay.
So, there are other tools that you could use to do that a little bit faster if necessary. But yeah, that's kind of the standard workflow, is about an hour and a half at 160 C to guarantee the full cure. And again, if you wanted to push speed, then we could think about, well, for a certain geometry, could you have a different heating system? We have played around with some inline post-curing units for like serial production, where you got something on a conveyor going through really hot. But yeah, 160 for 90 minutes is the standard.
And for the CoreCure material that you guys are releasing as well, that material itself is still the same time, scope, and temperature?
I think that one, I need to double check with my team. I think that one's going to be shorter. I think that one will be under an hour, but still 160.
Cool. That's good to know.
Yeah.
And then the final question is, this is kind of stepping outside of the industrial side and more in the medical or dental. It says, are you developing a range of colors within this polymer itself, say for use for dental use, for example, like tissue shade or tooth color shade? Is it a possibility or not?
It's definitely a possibility. In terms of stuff that we've sort of released publicly, the one we're ready to ship now is the lovely orange, as resin. We also have the capability of doing black, and we are working on different pigmenting strategies to get to different colors. I guess I would say, for this year, I think it's unlikely that we'll have CMYK any color you want by the end of the year. We've mostly been focused on get this out there as resin with crazy properties, and with some of these partnerships on the coating side, you can get the color you want through a very inexpensive post-process. But there's no scientific reason why we couldn't do the same kind of pigment dye color strategy that other photopolymers could do.
Right, absolutely.
And that said, for the specific question of like teeth and gums, I'm sure there's probably someone on the call who knows the like secret gum pink pigment concoction formula that gets the exact right color position. I certainly don't know it, but I'm fairly confident that we could find a way to make that compatible.
That'd be awesome. So that concluded all the questions that came through. Thank you to all the attendees for asking those questions. Those were all really good questions. And of course, thank you to the attendees for joining in. Raymond, thank you so much for your presentation. It was excellent. It was excellent to hear a little bit deeper about polySpectra, and even more exciting how it's now available to be used on the Asiga line publicly, not just as at your center, but also publicly. If users are interested in printing it and obtaining the material, they absolutely can. If anybody has any questions directly, I see you have the email support@polyspectra.com.
Yeah, that's kind of the broad reach out for customer inquiries is the support@polyspectra.com. And the main link that we shared earlier for the resin specifically is resin.polyspectra.com, but you can also just check out polyspectra.com, and we're happy to help and excited to answer any more questions that folks have, and excited for this to come out on YouTube and answer questions in the comments. We can do all of that too. So awesome. Thanks again. This is really fun, and really appreciate you taking the time to host me here. And I will see you in a couple weeks for the 3D printed dirt bike in Detroit.
Absolutely. We'll see you in a couple of weeks. And once again, anybody that's going to be at Rapid, stop by the booth, check out the parts, check out the bike. Raymond will be there. I'll be there. And of course, if anybody has any questions that's on this webinar or later on YouTube on the hardware related aspect from Asiga and wants to know more information about our printers, please email us at info@asiga.com. And of course, if you have any questions about the polyspectrum material, you can ask it then, and we will go ahead and get you in contact with Raymond and his team. Thank you all. Thank you, Raymond. And I hope you guys have a wonderful day.
Awesome. All right. Take care. Thank you so much, Corey. Bye,
Yeah.
everybody.
See ya. Bye.